have a bunch of dedicated channels. So for example, there's a dedicated channel for newbie programmers. So for new programmers to Go, there's a golang-newbies. And you can just jump in there and ask any question without being afraid that you'll ask like a silly question or something, and people will actually be helpful and get you the answer. Should we start?
I think we can start.
Well, I don't know what
okay, now it's Florin Pățan and production ready Go services in 30 minutes.
Okay, cool. So, hey everyone, thanks for coming. I hope you have a good time here at GoLab. My first time here, so yeah, let's see how this one goes. I'm a developer advocate for Golang IDE at JetBrains. That's my day-to-day job. I'm a gopher for a few years now, like 5 or 6 years. But today I'm not going to speak about the IDE or what I do at JetBrains and so on. I'm going to actually show you how, after a few years, I realized that I'm building Go microservices or services, and like what's the thought process behind that, like how I apply myself, like all the knowledge and so on, to actually building a service that runs on the internet. So what we have here are my contact details. If you ever want to ask me any question, Go-related, programming-related, job-related, feel free to either write to me on Twitter, mail, or go for Slack, as I was saying earlier, or grab me after the talk. And that being said, I actually don't have any slides today. So that's pretty much like the only slide that you'll see. It's going to be a live coding session, so it's going to be either terrible because I'm using the latest nightly build of the IDE, or it's actually going to work. So let's see how this one goes. So here what I have, it's the classic hello world example. And like if I actually go here and run it, you'll see it takes a bit of time because my laptop is one of those really, really slow machines that doesn't really understand how to CPU or anything. So don't be scared if you see it like slow, it's normal. But the point is, I'm not really sure if you can see it in the last row. I'm gonna try to make it a bit bigger, but like that's what you get for staying in the last row. It works, right? So we have a hello world. So let's convert this one to like a proper hello world in HTTP first, because we want to write a service, right? So the first thing that we kind of need in Go is to have a MUX or a router that you have in other languages. So to do that, you do something like new MUX, and you have the HTTP package which provides us that functionality. I said it's a router, so like we need a route to access that message that we want to print. So we have the handle func method, which allows us to actually bind a path, so let's say the slash, to a response function, so to a handler function. And we can do that pretty much with what we have here. That's the standard signature for the function. It accepts a response writer, and it accepts a request coming in. So using the response writer, we can actually write a message. So because I'm lazy like this, I'm going to just take this message that we want to print, and I'm going to use the write message here, and I'm going to convert this onto a slice of bytes, because we want a slice of bytes. Now, you may notice that my editor was like, yeah, you have an unhandled error. I'm going to handle it the classical way of ignoring it. Right? So, yeah, we also want to start the server, actually. So we have the listen and serve method that we need to call. And we should call this on an address and using our MUX as a handler. So with this bit of code, okay, let's handle the error here at least. Let's be good citizens. So if we do RRE, and let's do this log fatal. So we want to handle the error in a more explicit way. So we can say our server trashed with this message, have like a new line at the end, and that's our error handling. So with like, what, 6 lines of code, we have a bit of a HTTP server running now, right? So that's like the hello world of HTTP servers. Let's test this on and see how this works. So I'm going to run this again. And I don't have anything to guide myself on like whether the server actually started or not. So we'll actually run the request and see what happens. So if I run the request to our local host, let me close this part. So we actually see that our server replied, we have some headers, and we have the response message. And we actually see that my laptop is terribly slow because it took 21 milliseconds to write hello world, which is not that good. Right, so going back to our main function. Here, what else can we do? So one of the things that we can do is we can put the message outside of the function. So we can actually take this one into a constant because we may need it later on in the talk. I don't know why. And something else that we can do is we can take this error handling from here. Let's make it a bit nicer to see. I don't particularly like this like very long lines especially when I have something like listen and serve and so on, because it makes it harder to notice what happens. Right, so it's kind of the same code. We haven't done anything special. And I said we want to have like a production grade service, right? So production grade service usually means TLS or HTTPS, right? And now to expose that on the internet, there's a really good article from Cloudflare, which explains like the whole thing. What configuration you should have, why you should have it, and so on. And I'm going to cheat on this one. And I'm not going to write that whole configuration myself. I have something that I have predefined. And this is the link towards the blog post. So if you want to take a picture now, feel free to take it. If not, you just need to like Google exposing Go on the internet. And you'll find the article from Cloudflare. And it's a really great article. And it explains all the things that I have in here related to like what curves I have and what TLS version I need to have and so on and so forth. So it's a really good explanation of what you need to do to configure your server in a secure manner. Another thing that I can do now, so I have the TLS config, is I can have a custom server. And why do I need a custom server? Well, I need a custom server because if I use the HTTP handle or HTTP listen and serve, like I did earlier, it's going to use the default server that the net HTTP package exposes. That default server doesn't have some timeouts set correctly. And by correctly, I mean in a way that won't crash your production system if someone does nasty things like start sending a request and never finishing it. Like the default timeout for read, I think it's about 10 minutes. I'm not sure if they changed it meanwhile or not, but it's like that for like ages, like probably from Go 1.0. So I definitely don't want to wait 10 minutes for a request to finish, because then someone can just send me a bunch of requests that never finish. And in those 10 minutes, I can probably crash any server that I have, regardless of how big the machine is, right? And another thing that I can do is now I can use the custom TLS configuration that I have earlier, right? So that part works as well. And another part that I can do, let's go up here, I can use some environment variables to configure my service. Now, you probably can use environment variables at your workplace, but you can also use something like, let's say, etcd or something else to read your configuration from. In my development environment, usually I have environment variables. In my production environment, I stick with them as well. So yeah, and we also need to specify, as you can see here, a certificate file and a certificate key file. I generated some of those for my local development purposes, but normally you can pull them from, let's say if you're running Amazon, maybe something like a KMS service, or another service that provides you like a secure way to store the certificates. And that being said, now we have a custom configuration. We have the router initialized and prepared to serve requests, and we have the server that's custom configured. So let's start using that. And to do that, we just need to change that line and say, instead of listen and serve, we have listen and serve, TLS, and we have either a certificate file that we need to use or the key file that we want to use. So basically, in the few lines of code, and let's say we always configure those the same and this the same, in about the same amount of code, if we ignore like the static configuration and so on, we now have a custom service that can listen TLS configuration. So how can we verify that is, let's go back here, run this again. And to prove that I actually have the certificates here, they're generated in, like, pre-generated from a website, right? And if I go here, well, this one is on HTTP. So let's run the HTTPS version. Well, sorry. So now I run a request towards the local host, but it's on HTTPS, right? And I still got the response. So it means it all works. Another cool thing that I can do, and it's one of the tricks that I've learned while developing Go and figuring out how to optimize my performance and so on, was at some point, if you read enough about how NetHTTP works and how the handlers work in terms of providing you the header that says, oh, it's a text plane or it's a object and so on that you're serving back as a response, is that it actually takes a bit of time to do that processing. So all the detection that Go does to see that message is actually just text takes a bit of time. So we can help Go on this one, and we can say something like the content type should be text plain. And by just setting that line, you speed up your application by just a tiny bit, but it might be enough not to have to do other optimizations. And the other thing that you can also do is write your header, and let's say status OK for this one, because we do have a status OK. And since we do have a service here, let's convert this to application JSON really quick. And if I do this, sorry, JSON. So now I can like properly serve a JSON microservice, right? So that's how a service can look like if you do it like the bare bones and so on. The next thing that would be logical to do is, well, we want to grow the service, for example, right? And besides growing the service, like we have this part from here, the TLS configuration and the service configuration, which doesn't really change that much between services. At least in my case, it's usually the same TLS configuration and the same service configuration. So what I can do here is I can extract it into its own function and say this one is a new server, right? And this gives me the ability to like properly separate my code that actually needs to be in front of my eyes with the code that doesn't really need to be that much. What we can do here, we can also, let's say, so there's one thing that we still have as a configuration, we still have this one, the service address. And in order to properly decouple it, we can go, let's say, here, and we can say, oh, I want to add the address to be a string. And right, so now I can just like pass all the parameters that I need to the function. Of course, if you want to further customize this, like if you want to change the timeouts and so on, I recommend building a configuration structure that you pass to the function. I have only 2 parameters, so it doesn't really make sense to like complicate things for now. I can still use plain parameters and see them, and so on. And as I said, I'm going to reuse this a lot. So rather than reuse this only in my current code, because I'm in the main package, let's move this one to a different place, to a different package. And let's say I'm going to move this one to like a server package, right? And what else do I need to do? I need to export this one so that it's actually available from the main function, right? So now I have all the service server init part separated from my main code, right? And if I go back here, I have a bit more clean code that I can look at. So I can see, oh, I have the service here. I know that I'm building a server here. I can test that part independently if I really, really want to. Although, if you look at it, so looking at it here, like, what are you going to test? Test that you can assign values to a structure? Like, it doesn't really make sense. So if you really need code coverage in your tests, you can ignore this package safely, because there's not much you can do here. Like, I can't think of a test that would cover that part and be reasonable to write. And another thing that we can do here, let's start moving this one to its own handler. Sorry. And the reason why I want to do that is because I want to test this function at some point, right? So if I have it as a closure inside my main function, it's harder to test. And I said production-ready services, which means tests. Right, so now my code looks even better if I look at the main function, because I know, oh, okay, so I'm handling this, I'm creating the service, TLS, and that's it. I'm done. One thing that you can do in Go is organize your code with packages, right? And if you read on the internet blog posts from JBD, from Peter Bergon, from Bill Kennedy, and so on, they all talk about how to structure your packages based on the functionality they provide. So, for example, instead of structuring your packages like the classic MVC model from other languages or frameworks, what you can do is take your package, and let's say in this case we have a home handler which should handle the home page, right? So where should I put this function in? Well, I should put it in a homepage package. And that package should contain all the functionality related to my homepage. So that means everything that I need to render and so on that page. If I would build a shopping site, I would probably have a package called cart to have all the cart-related functionality. Package called users to have all the users functionality. And probably a cart users package, which does the link between the two packages in case I actually have a cross-dependency between them, so that I can avoid the circular dependency between the two of them, as Go doesn't allow you to have circular dependencies between packages. So having a way to organize the code like that helps us build a model of our application, and not only like how it works, but also having a look, let's say at 3 a.m. in the morning, when your user module fails, you know you can go to the user package and that's it. Like if there's, like, you can identify code a lot faster based on how you structure that. Oh, and there's also a good talk from, I'm gonna spell her name really wrong now, Kat Zien at GopherCon UK or Iceland, either of those. I highly recommend that you see her talk as well on how to structure your code. So for now, I'm just gonna move this on again, as I said, let's say to the homepage package. Oh, okay. Should probably export the function, and I should probably move the message as well, so that I move all the dependencies with me. Right, so now I have a separate package with my handler. I can add more handlers here if I really need to. And it's gonna be separated from the main function, which means I can test that a lot easier, right? Also, if I look at the code here, it's a lot cleaner. Like there's like 6 lines of code, which is what we started with in the beginning. But all that complexity that we now have and built upon, it's hidden away when I actually start as a new programmer on the application. And I can navigate through it easier because I can see, oh, I'm handling that part here, and I have the home handler. Or I want to go to see where I'm building the server itself, and I can go to the new server package. Or if I should name it correctly, because we are in Go, I should probably name this new, because it's usually idiomatic not to name things as the package they have, right? So that's pretty much it in terms of structuring. for packages. Another thing that we'll probably want to do is, let's say we want to inject some dependencies, right? Or we want to somehow, let's say we have the log function here that we call, but we want to call the log function inside our handler here. Sorry. So if I were to say log.println in home handler, sorry. So if I were to say something like that, well, I would probably hide the dependency on the log package from my callers, which is not ideal. Ideally, I want to have all the dependencies clearly visible from the place where I call that method or function, so that I can A, test it, B, debug it, without having to run into complex scenarios of thinking, okay, so maybe I'm pulling the data from there or from there. So how do I do that? One way to do it would be putting this on a struct. So let's say we have a type home page, which is really against what I said earlier, but like I don't have an inspiration right now. And here I would have something like this. I would put my function, let's say h on the home page, right? So now I have a method with that, and I said I want to depend on the logger. So let's have a constructor here. Constructor, let's say new home page. Okay, that's fine. And I want to inject that. So how do I inject the constructor, like the logger function to that place? So one way to do it would be to do something like this. The logging package allows me to build a custom logger. So if I have something like this, let's say logger new, sorry, log new. So I want to write to std out still. I want to prefix this with, let's say, GoLab, and that's it. And I want to still have the standard flags, lstd flags, and I also want to have, and this one is a nice little flag here, l file, okay, I forgot the actual name, l short file. So there's an option to the logger package that you can actually pass the L short file, and it's going to print the name of the file and the line where you call the logging function for you. So we'll see that in a second in action. And for me, at least in my use cases, because I name the files in a certain way, I can usually look at the line of log and figure out by the message and that file what my error is and what happens in my code without having to do too much work. So that's pretty important. Let's build our homepage for now. So we have homepage.new, and I said we want to pass this as a function, and then I have this one here. So let's refactor this one as well. We want to accept a logger, which is of type logger, and I think it's a pointer, if I remember correctly. Okay, I'm gonna pass this on to the home page. Here, I'm gonna add the logger field. I know, it's a bit boring, but we'll get to the fun stuff in a second. And if I replace this one with h.log, so now I've injected my dependency into my handler. I can clearly see when I build my structure what dependencies it has. I know how to inject them during testing. I know how to do logging in a consistent manner. And if I actually remember to do this, which I always forget, So if I do L print line service started, let's see what happens. So as you can see, it takes a bit. Okay, so my service started. I see the prefix that I have. The standard, the LSTD flag that I had earlier here gets me the date and the time. And now the short flag gets me main.go on line 33. So I know where that message comes from, I know how to navigate it, and so on and so forth. And if I do a request, so if I go back here, so this one still worked. And more so, I have the line where that message came from, right? So that's cool, right? We now have logging in our application, but we can do even better. And by that, I mean, I said we want to add more handlers. So one way to do that is using middlewares or wrapper functions, if you want. So let's build a wrapper function for our package, right? One way to do it is something like this. So we have let's say home page here. With logging. And what do I want to have here? Well, I want to have the same signature, and we'll see here in a second why I want that. Response writer, and R, which is an request. Right. So what I can do here is I can return an HTTP handler func, which is basically what my home handler is. And I know it's getting a bit longer than I like to, but like that's the signature. And what we can do here is we can return our function, right? So we return what we are interested in, our wrapper, in which we say something like now it's the, or let's say start. Time is time.now, right? We want to call our handler, and here's what I did wrong, sorry. HTTP handler func. So I call our actual H, which is, so I'm gonna push my function as a parameter to the with logging function, and then because I'm terrible at naming handler, I have a conflict with names because I already named something H. Right. So now I have the start time, I have the handler function, and I can do something like this. I can say h.logger print line formatted request to, let's say, to which page took time, right? So I can do something like this, and I can now have access to request URI, and I have time now sub start time. So I can basically have something like this available. So I'm taking the time of the request when it starts, run the handler, print the time at the end. And it's all nice and shiny, but it means that I have to go back to my main function and change how I do things here. And one thing that I learned is that I don't like this. And why I don't like this is that I kind of want to have all my handlers and the way I wrap them inside the package that I actually use. So what I can do here is I can say h.init routes. I can go back here and I can say, oh, add me a mux, which is an HTTP mux, right? So now my package has control over the routes it exposes, but I can also have control as a programmer over what it does with those routes. So I don't have to go back here. basically. And I can just pass this as a parameter. And again, my code is still readable. I know what happens in there if I look at it. And it just works, right? So if I go back here, I can say something like H with logging, H home handler. So now when I run the request to my homepage, it's going to run through the wrapper function, and it's going to give me that. And I can get rid of this line of code here. I can probably do the same with the content type if I have a proper content type and so on. So basically, that's kind of it in terms of how to structure your application. And let's talk quickly about the tests. So I said we want to write tests. And I'm not going to really subject you to writing tests in Go right now, because this one is a bit longer. So let's go here. Sorry. So I have this package, and normally if I would write a test, I would probably need to start with something like this, and then have like the whole testing done and so on. How many of you have you heard about table testing? Okay, so I can teach you something. So what table testing is the whole bunch of text that I just wrote. But moreover, it's a way to structure your tests so that they basically contain a slice with a type of struct as elements. And in there you structure your inputs, outputs, parameters, and let's say, for example, the name of the test to identify it easier. Because I have no clue how to name things, I named this one the good test. The point is, now I can add more tests to this, being a slice, and I don't have to do anything else in my logic in order to test different, let's say, different routes if I want, or different scenarios. To do this, so new homepage, because I actually changed the code a bit, and yeah, as you can see, it's all live demo. And the home handler, I can run this. So what the code does is now I'm ranging through the suite of tests that I have, through the whole slice of tests. You may look at this one and say, hey, Florin, you have like a not useful assignment there. So there's a catch to that. If you want to run the test suite in parallel, because you're ranging with values here, Go will actually not give you the test you are expecting in that iteration. It's going to give you always the last one, or a different test than the one you are expecting. And if you've been in Bill Kennedy's workshop yesterday, or you've read on the internet about how the whole mechanism works with pointers and copy values and so on, that's why the line is here. We basically shadow the variable, but it's one of those cases where it's a good shadow of the variable. We take a new value, basically. From here, we take the value here and assign it to a new variable, because we can do that in the block of the for function. So once we do that, we can actually call test.run, and now we have access to our structure here. And let me see if I can collapse this one. Okay, I was a bit too eager. So I see the name of the test, and I assign it here. So now it's easier to identify where the test is. And then what do I do? Well, I do basically what my code does, almost. I take a new homepage handler. I don't want to test the logging part for now, so I can just ignore that out. And I'm executing my handler directly. So I can just see, okay, if I provide you a proper request, do I get a proper response back? And in order to do that, I'm using the HTTP test package. The HTTP test package is under net HTTP test and gives you some convenience functions like this one, new request, which allows you to build a new request, as the name says, for the HTTP handlers to use, for example. Or you have the new recorder, which is basically your response writer interface implementation of a type that then gives you access to things like your response code. So now, whenever your code will go back and say, write header, you can, so I have the call here, which is status OK, right? So how do I test that one back? Because if I look here, the response writer part is an interface, so I don't have access to it. Again, it's only write through, and that's it. And that's where the HTTP test package comes in with the new recorder and allows me to do something like, give me a second, and allows me to do something like this. I can now have a look at my code, at the response code, and test it against my expected status. And the same goes for the body of the response. So I can properly test if this works or not. Can I add more tests? Sure, I can do, but I think we're running out of time. I can run this to see that it actually works. And it takes a while to compile. But the point is that now I have a structure which I can use and replicate to other tests as well. I can write tests that fail intentionally, and I can do so with either touching the dependencies that I have or not, right? So now if I look at this one, I can see that my test handler run, and the subtest named good run as well. So everything is good and green. What else? You may say, well, I want to inject a database connection. How do I do that? Because it's a database connection, it's something that's going to live as an object between requests, right? So because it's going to live between requests, the way to do it, the way I recommend to do it, is have another field here on your structure called, let's say, DB. And let's say if you're using the SQL package, well, give me a second, it's SQL.db here. So something like that. And the way to do it, well, actually, wait, I'm silly, sorry. Field, and this one is of type DB. So the reason to do that, and then I should pass it as a parameter to the function. And the reason to do that is that the object will live across requests. And then it's going to be also, again, easier to test, easier to figure out and mock, easier to see as a dependency in your code, so you don't have surprises. If you would use the context package, because that's pretty popular, right? So you, for example, if I go here, I could be tempted to write something like this, context, and then like get the value and say DB connection, right? So if I would do that, yeah, I can do that, but then I need to verify that my object is there. I need to verify it's not nil. It's of the type I expected it to be, and there's no other package that, meanwhile, I don't know, or someone else that hooked up with a middleware which actually overrides my value, and instead of being a SQL DB pointer, it's now a Florin DB pointer, because Florin was trigger happy and said, well, I know better, and I want my DB connection to be that. So there's a lot of complexity in using the context package correctly, and I highly recommend that unless you have things like, let's say, auth tokens. You want to carry the auth token with you throughout the context of your request. That belongs to the request. So it's scoped to the request itself. Don't worry about that particularly. You can assert on that and use it. It's not going to leak outside of your request, right? It's not going to be used by a different user. It's going to be the same token just for that particular request. So that you can put safely in the context. Don't put your DB connection. Don't put your logging middleware. Don't put any other objects that are long-lived. So that's that's one of the things that if you take away from the talk, do that, please. And I think I have a game over flag. So like, if you have questions, I'm happy to take them now. If you are hungry, go. And you can catch me. I'm going to be around here all day. So yeah, thank you for coming. I hope you like it.